What is up people, and welcome to another video on the Kubernetes Lightning series. In this video we'll be taking a look at Kubernetes secrets. What a secret is, why secrets even exist, we'll take a look at container mounts, how to mount sensitive information into containers, and how Kubernetes allows us to automate this using Kubernetes secrets. When we deal with applications, we often need to provide sensitive information to applications using files or environment variables. When we run these applications in containers, we can use volume mounts or environment variables to pass the sensitive information to our application. And today we'll take a look at how do we automate this. So we'll define this sensitive information using a Kubernetes secret and look at how to mount these Kubernetes secrets into pods. We'll also discuss why secrets exist and the framework that Kubernetes allows us to work within when it comes to dealing with secrets. So it's not just secrets, it's all about encryption, decryption, handling sensitive data and securing secrets, and also things like Vault. So without further ado, let's go. So the first thing I always like to start with is the source code. If you take a look at the source code, this is the Docker Development YouTube series GitHub repo. And in here I have a Kubernetes folder. And if you scroll down inside the Kubernetes folder, you'll find a secrets folder with a README. And this is the introduction to secrets. And it has all the steps we'll be taking a look at today and links to the official Kubernetes documentation. So make sure you check out the link down below to the source code so you can follow along. And I usually start off these tutorials and demos by firstly creating a Kubernetes cluster. If you don't have one, you can use a utility called Kind to create a cluster. In all my videos, I like to use a lightweight Kubernetes cluster. In this case, I'm using Kind. Kind is a lightweight Kubernetes tool that allows you to deploy Kubernetes nodes as a cluster in a lightweight Docker container. This allows you to quickly create many clusters. You can create one for every project that you're working on, and you can just delete it when you're done. They're very lightweight, and it doesn't need a virtual machine. It is used by the official Kubernetes open source team to build and test Kubernetes. So it works for almost all use cases. And to demo secrets and work with secrets and test all these kind of features, I use a Kind cluster, and you'll see how easy it is to create. I just say Kind create cluster, I give the cluster a name, and I give the image I want to run. In this case, I'm using the Kubernetes image for 1.31.1. I go ahead and copy this command, I jump to my terminal, paste it, and that will go ahead and create a Kubernetes cluster that we can use for testing. And you'll see that this just takes a couple of seconds to run. And there you go, it's done. If I say kubectl get nodes, you can see we have a one node Kubernetes cluster. Give it a couple of seconds and you'll see it's now ready. When you use Kind to create a cluster, it automatically configures the default kube config. In the first couple of episodes, we've taken a look at Kind, we've taken a look at creating our first container, and we've explored kubectl. If you're new to Kubernetes, check out the playlist down below and start from video 1. So now we have an empty Kubernetes cluster that we can use for testing. So before we just jump right in and use this Kubernetes secret and take a look at it, we have to understand why secrets exist. For a lot of people that are new to Kubernetes, they get lost by just looking at Kubernetes documentation, trying to wrap their head around the concepts. It's very easy to understand Kubernetes concepts when you take a couple of steps back and ask yourself why it even exists. So first things first, applications require sensitive information sometimes, like sensitive configuration files. For example, a microservice might need access to an S3 bucket or a database, so it uses a database connection string. You might have a payment service that integrates with PayPal, and it might need a token or API key to talk with PayPal and authenticate. APIs often use tokens to authenticate to other APIs. A secret can also be a TLS or SSL certificate, usernames and passwords. Basically, applications need sensitive configuration configuration files a lot of the time. And these configuration files are no different to normal configuration files. But Kubernetes has decided to split these two because they are handled differently. That's why we have secrets and we have configurations or config maps. Configs and configuration files can generally just be checked into source control. But secrets, we can't just check it in blindly, or at least we shouldn't be checking in our secrets into source control. Now there are solutions like sealed secrets and methods of encrypting a secret and then checking it into source control, but generally among security folks it's not a good practice to check secrets into Git. This is where things like vaults and secret stores come in. Things like LastPass, Keeper, KeePass, Bitwarden, and all these other tools that manage secrets. This is because there are a lot of controls when it comes to secret stores that have to satisfy auditors and auditing. When companies go through audits, they have to satisfy a whole bunch of criteria. That is why some of these products exist. So we covered that applications need sensitive files. Now, how does this work? When we stop running applications on virtual machines and we start running them in Docker or containers, we use things like Docker, Containerd, Podman to run containerized applications. Containerization has a concept of mounting that allows us to mount configuration files into applications. So if you do Docker run, you can mount a sensitive configuration file into the container, and that container can then access that file. There are two main ways to pass sensitive information to containers. One is a mount, so mounting a file into a container. The other one is an environment variable. We can set an environment variable and pass things like API keys and tokens into containers as well. So now we know applications may need some sensitive information. So let's take a look at our secret. So let's say we have a secret and this is just an arbitrary JSON file that lives in our Kubernetes secrets folder. I have this file checked into this repo so you can check it out. If I go to the terminal and I just type cat and print out the content of that file, you can see it's a simple JSON file that has an API key and some secret value that would go there. So this could be any sensitive file that you have on your machine. It could be a TLS certificate, secrets, configuration files with sensitive information like connection strings to cloud resources and so forth. So we have this file. How does our application use this file? Now, generally in a containerized world, if you're using something like Docker, we generally use two main methods of achieving this outcome. We can either use it as a file, so we can mount in by creating a Docker volume. We can mount that secret file into the container. So I can do something like Docker run, and I can run a new container. I'm just going to run an Ubuntu latest, and I'm going to run bash, so we can go inside of the container. But this is the mount specification. You have to be familiar with Docker mounts in order to understand the whole Kubernetes config map, volumes, and secrets concept. Because it's not just for secrets, it's also for configuration files like config maps. And in the future, if you want to run databases and things in Kubernetes that need to persist files, you need to create volumes and volume mounts and look at storage plugins to achieve that. But taking a couple of steps back before we even get to Kubernetes, we want to understand the volume mount concept. So volume mount specification starts with -v, and then we have two parts. It's separated by a colon. The first part before the colon is what do we want to mount into the container. This is the path to a folder or file on the host machine. This is the file we just looked at when we ran that cat command. It's under Kubernetes secrets and it's called secret.json. I want to mount this file into the container, so it goes on the left side of the colon. On the right side of the colon is the location of where it will be mounted inside of the container. So when we run in Kubernetes in our pod, the file will end up here. So you can already kind of get the idea that Kubernetes is just an automation tool. There's no magic. Kubernetes behind the scene will craft this sort of command and then run the container. Now Kubernetes uses something called Containerd. As a runtime, it doesn't use Docker. But Docker and Podman and all of these tools use the open source specification to run containers anyway. So volume mounts are the same across all of them. So there's nothing fancy to this. So the left side indicates the file we want to mount in that's on our host, our host would be the Kubernetes node in this case, and the right side is where it's going to be mounting into the pod or the container. Now, Kubernetes does the automation of creating this file on the node, somewhere on the node, and mounting it into the container. Kubernetes automates that, it handles that, and we'll take a look at that in a bit. If I go ahead and take this command and copy it, jump into my terminal, I'm just going to clear that and paste it. You can see we are now in our Ubuntu latest container in bash. That's because we ran Ubuntu latest and we passed bash as an entry point. And what I can do now is I can run the cat command and I can just say cat secrets and secret.json, and you can see there is our secret file. If I go ahead and change this file on my host, it will reflect in the container. So this is one way of passing a sensitive file into our container. Another way to do this is using environment variables. The reason why I'm showing you file as well as environment variables is that it's very important in Kubernetes to understand both, because a lot of open source applications may not accept the file. It might only purely be using environment variables or a combination of the two. So it's important to understand both. If I jump back to my terminal and I just type exit to get out of the container and clear it and go back to our document, we can also use environment variables. So we can say API key equals some value. So go to the terminal, we can run this command to set an API key. This will work in Linux, but because I'm in PowerShell here, I'm just going to add $1 in the front. That defines a variable. Now in Kubernetes will just go ahead and automate this. So it'll grab this value from a secret and it'll create an environment variable. And then we pass it in by saying docker run -it, and we use the -e flag to indicate we want to create an environment variable. And then the E flag takes in keys and values. So the key is the environment variable name you want to call, in this case API key. That could be the environment variable that the open source application or whatever it is in the container is looking for. And then just the value that we want to pass in. That is the variable API key we've set up here. So if I go ahead and copy this line, jump to my terminal, paste it, we're now again in the same container. But now we should have this environment variable inside the container. So you can go ahead and just grab this name. You can say echo $API key, and you can see there's the value. So containers allow us to mount files, and it also allows us to pass environment variables. Kubernetes automates this. So if we create a Kubernetes secret, it'll take the content of that secret and create a file mount and mount it to our container. It handles all of this for us. We can also take components out of the secret and pass it in as an environment variable. We'll take a look at this as well. So now you know and understand how applications running in containers get their sensitive information. Now the important thing to understand is that Kubernetes has no magic. It's purely automation on achieving the same thing. So Kubernetes will take our secret that we create, and Kubernetes is a declarative type of language. It allows us to declare and declaratively define our secret as a YAML file, and then declaratively define our pod. And in the pod we can say what secret we want and how we want to get that secret. Do we want to use environment variable, or do we want to use a mount, like a file to mount a file, or do we want to use a mount point and mount a sensitive file? And then we tell Kubernetes which secret we want to point to and use. Kubernetes does the automation of taking that secret, taking the value out, creating a mount point into the container, and doing all that heavy lifting for us. Remember in the first couple of videos on the series, we talked about desired state. Kubernetes is all about us defining what we want, and then it just makes it happen. If the secret does not exist, the pod will fail to create, and we'll need to use the kubectl describe command to work out why. And in the events, you'll see that the secret is missing. So that's one misconfiguration. You got to remember the secret has to exist. The other one is you want to make sure that you get the mount points correct. Your application may still crash if it's looking for a secret in a specific location, and we got that path path wrong. Let's say we used secrets instead of secret.json or secrets.json, or just some sort of misspelling. Linux is also case sensitive, so we want to make sure we try to keep everything lowercase, because secrets.json with a capital S is different to secrets.json with a lowercase s. So now that we understand secret mounting into containers, let's take a look at Kubernetes secrets. So I've left a link to the Kubernetes secret documentation over here, and this takes us to the official Kubernetes document for secrets. And a secret is an object that contains a small amount of sensitive data such as a password, token, or a key. Such information might otherwise be put in a pod, spec, or a container image. But if you're using secrets, it means you don't need to include confidential data in your application code. So this is the whole thing about containers, is that we do not want a secret sitting in our container image. So we do not want to inject secrets during Docker build and still have them left behind in the container image. So be very careful of that when you're building container images. Secrets and configuration should always be abstracted away from your container. So you should be mounting it in. That means when you're running a production container, you can mount a production secret. When you're running a dev or a UAT container, you can mount a dev or a UAT secret. That allows you to use the same container image in your development, UAT, staging, and production environment. I see a lot of the time people building a container image for each environment, and that creates a lot of waste. It also means you're not really using and testing the same image, because you're testing one image in develop and then you may run a different image in production. So you're basically testing apples and oranges at this point. So try to always use the same container image and mount the secret in. And when you're doing this, you're using different mechanisms and different workflows to transport that secret. In this case, we're going to be using Kubernetes secrets, but you can also take a look at my series on vaults. This allows you to bring the secret from somewhere else. Kubernetes also has a lot of secret mechanisms. So you can inject secrets from a cloud-based secret store, something like an Azure Key Vault, or something like an AWS secret manager. You can bring secrets from external systems and then end up moving them into a Kubernetes secret and have mechanisms of mounting them to pods. So decoupling secrets from your containers is essential. But when you start your journey with Kubernetes, you'll want to just start by using Kubernetes secrets. And you can always have a look at vaults and whether they are needed later. The document talks about the different usages of secrets, like setting environment variables and providing credentials and files to containers. We've taken a look at this already, and there's an example here of how to define a secret as a YAML file and then using it in a pod. And we'll take a look at this in a bit. The important one I wanted to show you is the type of secrets. There are different types of secret. When we define a secret in YAML, the basic type first is called opaque, which is an arbitrary user-defined data. This is anything like a JSON file, application configuration file, or any kind of key value pair. Any arbitrary user-defined data. So most of the time you'll be using this type of secret, but Kubernetes does understand a bunch of other ones like TLS, which is like a TLS or SSL certificate, or SSH, like an SSH authentication, SSH key, or basic auth, which is used in HTTP, credentials for basic authentication. So in this video, we'll use the basic, opaque, arbitrary user-defined data as a type of secret. So how do we define a secret in Kubernetes? Let's take a look at our source. So on the left side here, I have the Docker development YouTube series, GitHub repo. We got the Kubernetes folder, and in here we have a secrets folder. We've taken a look at this secret.json, this containing our API key. So you can start with just having a file locally, and you can use kubectl to take this file and place it as a secret in Kubernetes. That is one way to do it. You can also go ahead and create a secret YAML file yourself if you want to. So if we take a look at our secrets folder, I have already done this by creating a secret.yaml for us. And as we've discussed before throughout the series, Kubernetes uses these couple of fields on all objects: API version, and for secrets this is v1. The kind is called secret. This indicates that we're dealing with a secret file or a secret object. Then we have metadata. Metadata is where you store things like name, namespace, and labels, as well as annotations. All Kubernetes objects have these fields. So our name it's just going to be called my secret. This is the name of our secret. The name is important because pods and deployments that want to use this secret will reference the secret by name. And namespace is not something we have to define because we can use kubectl create or apply and then pass the namespace in at runtime when we want to deploy, but I'm just showing you that the namespace can be placed here as well. And then we have labels. We've learned that labels are important when we want to use object selectors in Kubernetes, but we won't be using that for secrets here. Then we have the type of secret. Now I mentioned opaque. This is because our secret contains arbitrary data. Now it is very important to understand that all secrets contain data. There's a data object. Data can either be data or it can be string data. In this example here, the difference between data and string data is that data is generally base 64 encoded, where string data is the unencoded version. Now generally in Kubernetes it is preferred to always use the encoded version. So this is generally how we would define the secret. You have the data field, and then you have key value pairs, and each key represents a file name, and the value represents the base 64 encoded content of the file. You can manually craft this using your terminal. So I can say cat that Kubernetes secrets secret.json. You can see there's the value there, but I can pass this to base 64, and that will generate me the base 64 encoded version. I can also decode this by echoing it back to base 64 and saying -d to decode, and this is how you encode and decode in base 64. It's important to know that base 64, this is not encryption. So just because you're looking at the secret and you're seeing it looking like this doesn't mean you can go ahead and check it into Git. Anyone that takes this value can decode it. Encoding and decoding is not encryption. Very important for newcomers to understand. It's just much easier to encode a file like this and then use it in YAML. Remember that secret.json has a format, and JSON has a format like quotations and special characters. And when defining JSON inside YAML, you can make mistakes and break the JSON format. There are other formats like XML files and things as well. Or if you have YAML inside of YAML, this can be really hard to deal with. For example, if you have JSON in YAML and you're passing this through APIs and Linux systems, depending on how this is handled, sometimes these quotation marks can be chewed up by a bash interpreter, as an example. So it's just much easier to deal with these sort of nested content by encoding it. So this is the default way you would define a secret.yaml in Kubernetes. But you can have the unencoded version like this by replacing data with string data. So what I'm going to do is I'm going to leave the secret like this in the recommended format. I'll leave this one here commented so you can take a look at it. Now, to create our secret in Kubernetes, there are two ways to do it. We can either use the kubectl create secret command. As we learned in the series, the kubectl create command allows subcommands that allow us to create objects in Kubernetes. We created pods and deployments and services. Similarly, you can create a secret using the same method. Or you can just use kubectl apply or create by passing in the -f flag and just sending it a YAML file. So we can use the kubectl create secret command. We pass in the type of secret we want, called generic. We can also use, instead of generic, other keywords to specify like Docker secrets or TLS certificates or what have you. Mostly you would use generic to just apply generic files. So we want to create a new secret called my secret and then say from file and point to the file that we have created locally. So this is not the YAML file. This will allow us to create a secret automatically from the secret file, from any kind of file. This could be a TLS certificate. It could be any kind of file. In our case, it'll be the secret.json. Behind the scene, kubectl will convert this into YAML and apply it to our cluster. So this is sort of the easiest way to create a secret if you have that secret locally. In my case, I have the secret locally. It exists in this path. So if I take this command, copy it, go to my terminal and paste it, it'll create our secret. If I do kubectl get secrets, I can see the secret right there. And remember, in kubectl, we can output things as YAML, so we can always go ahead and get the YAML afterwards if you need the YAML for some reason. You can say kubectl get secrets, give the name, say -o YAML. And now you can see we have the YAML right here. So API version, and there is the data we're interested in. There is the file and the base64 version of that file. This is often a way, if you want to troubleshoot to make sure a secret is correct, you can run this command. I use this to troubleshoot secrets quite often. Take the actual content like so, and then say echo, take that content, pipe it to base64 and -d to decode it, and you can see the secret content is there. This helps us look inside to make sure the secret is correct. Sometimes there could be a wrong secret inside, or it could be malformed if the developer has broken the secret for some reason, or applied an invalid secret. So kubectl create secret allows us to create a secret from any kind of file. We can use kubectl get secret to retrieve it, and use base64 decode to see the value. So that's one way to create a secret. The other way is to use the kubectl apply -f or create -f to define it from a secret.yaml file. In this case, we have the secret.yaml file over here. It looks similar to the output we've just seen before. You can go ahead and apply that. Say kubectl apply -f, grab that, go to the terminal. Just going to clear this terminal to make it neat so we can see what's going on, and I can apply it, and we can see it's been configured. So it's been applied. Kubectl get secrets. We can see our secret is right there. So now we have a secret in the cluster and it's ready for use. Now, before we go ahead and use the secret, I wanted to show you something else as well. At the moment, we're covering a file only. This will not help us when we want to mount secrets as environment variables. Now, luckily for us, the data field provides key value pairs. So what we can do is head over to our secret. We could take this API key and we could add API key here as well. If we take this value, we can pop down to the terminal and we can say echo that value, pipe it into base64, get the value out. We can head back to our YAML and paste the content in there. So we can provide key value pairs that can be used for environment variables as well. This is very important. So this will be used in cases where we want to use an environment variable, and this one will be used in cases where we want to mount a file. And to apply that, what I'll do is just jump back to my terminal and I'll just apply that change. And if we do get secrets again, -o YAML, we can see it has both values now. You can put as many keys and values here as you like. So now that we have our secret inside Kubernetes, we technically just have to automate what we've been doing with Docker run. So Docker run -v, we defined a volume and volume mount specification, telling the container runtime how we want to mount our secret into the container. We also used -e, indicating how we want to apply a secret or a sensitive value from an environment variable into our container as an environment variable. Kubernetes allows us to automate this by taking our secret and doing effectively the same thing. So we can define a volume and volume mount inside of our pod YAML or an environment variable. Remember, Kubernetes is a declarative language. So declaratively, we'll be telling Kubernetes where to find our secret and create a volume out of that secret. So that is the left side of the Docker run volume specification. Then the right side was where to mount it into the container. So we'll declaratively tell Kubernetes that we want to mount that volume into a specific path as a volume mount inside of the container. Simply automate what we had with the Docker run. Let's take a look at that. Now what I've done is I've created a new pod YAML in our secrets folder. So in our Docker development YouTube series where we have the Kubernetes folder, scroll down to the secrets folder where we've been working, I've got a pod.yaml right here. Go ahead and open that. Now, in order to mount our secret file into the container, we firstly need a volume. So take a look at the pod YAML and just collapse a few of the fields so we can see what's going on. Under the pod spec, which is the spec over here, remember that if you're looking at a deployment instead, the spec will be fewer levels down. But deployments also have a pod spec. spec. Remember in our deployment YAML video, we also had a spec inside with a containers and all the settings of the container. So it's exactly the same thing. So under that spec where you have containers, you'll find this in the deployment YAML as well. If you're working with a deployment, you will see your list or your array of containers, right? On the same level where the containers is, you will create a new field called volumes. Volumes live at the spec level of a pod, not the spec level of a deployment, but on the same level where your containers are defined. A new field called volumes. This is equivalent to the left side of the -v in the docker run command. We specify the name of the volume, we can call it anything, and we specify the type of the volume. In our case, it's a secret volume, so it takes this field called secret, and underneath this field is a name called secret name. So this field called secret name maps to a name of a secret. So we created a secret called my secret. This name has to match. If this name doesn't match, your pod won't start, as the secret will not be found. So that's all you need to do to declare a volume. But at this point, this volume is not used by the container. For this, we need to create a volume mount. So we have to take this volume and now mount it in the container. So to mount it in the container, we have to go inside of the container field, and inside the container where you have name, image, and all the different fields, you'll create a new field called volume mount. Here we say the name of the mount we want to call it, as well as the mount path. So this name over here needs to match the name of the volume. You can see the volume is called secret volume. That's the name of it. And here we're telling Kubernetes that we want to create a mount with the same name. So Kubernetes now knows that it needs to mount this volume over here. And here's the path to mount it at. I want to mount it to /secrets. So that's all we need to do. This will mount the secret file into a path inside the container. If we want to use environment variables, we'll do it slightly differently. Under the containers section, we can add a new field called env. This is how you specify environment variables for containers. So we can create a new one called API key, and this is the kind of mapping. This is the object used to map environment variables from secrets. So you say value from. Remember, environment variables takes names and values. If we have name and value, we can just hard code the value. But if you're getting the value from a config map or a secret, you say value from, and then you say secret key ref. This tells Kubernetes that you want to get the value from a reference to a secret, and the name is the name of the secret. So this is not using a volume mount. This is telling Kubernetes that we want to refer to a secret for this environment variable. So we need the name of it, my secret. This is the name of our Kubernetes secret, and then the key. This key is the key inside the data field of the secret. Pretty much the key inside the data field, which is called API key. So we've told Kubernetes enough about what it needs to know. It'll go to this secret, get this field out, and inject it as a docker run -e and pass it to this environment variable. So this is how you map environment variables from a secret into a container. So hopefully that all makes sense. Two ways to pass sensitive information to containers. Now to test this out, we've already updated our pod YAML to use the secret. So now we can go ahead and just deploy that pod by saying kubectl apply -f, and this one is under the secrets folder, and it's pod.yaml. Go ahead and copy that, go to our terminal, paste it, and that will go ahead and create our pod. kubectl get pods, we can see the container is creating, and after some time we can see it's running. Let's go inside. So remember, we have a command called kubectl exec, and we can say exec -it. This is equivalent to docker exec -it, gives us an interactive terminal into the pod. That's what IT means. We want an interactive terminal into this pod. We have to pass -- and then indicate the command we want to run inside the pod, and I want to run bash. Bash is not available in this container because it's an Alpine container. I have not installed bash, so we can use sh, and then I can say cat secrets and secret.json. See there, our application now has access to that secret, so it's mounted as a file as well as API key, which has also been added as an environment variable. So that is how you use secrets in Kubernetes. Now, a couple of footnotes and tips around Kubernetes secrets. Secrets in Kubernetes is just simply an automated mechanism providing a place to store secrets that's very simple, and then allow the automation of moving that into a mount or an environment variable and injecting it into a container. It's purely an automation flow. Kubernetes provides the framework to build any more secure solution on top of this. It's not up to Kubernetes to make this super bulletproof and secure for banks to be able to use. It is up to you, the user, to work out what your requirement is. For most microservice environments, Kubernetes secrets are sufficient. You can tell Kubernetes, depending on where you've deployed it in the cloud, you can tell Kubernetes to encrypt secrets at rest, and it'll do its best to make sure secrets are protected in the API server database where it's stored, which is etcd. But it does not give you PCI grade compliance and will satisfy all the auditing needs if you're like something like a financial company that stores secrets there. This is where things get more complicated, but it's not up to Kubernetes to solve it. Kubernetes provides the framework that allows you as an engineer to solve it yourself. That is why there are so many open source tools and integrations into Kubernetes. One example I mentioned is people often want to store secrets in Git because GitOps has become so popular, like Argo CD, Flux, and all of these GitOps based solutions. So why can't we put our secrets in Git? Well, as we know, we shouldn't be checking in sensitive information to source control. However, there is an open source product called Sealed Secrets that allow developers to work with kubectl create sealed secret instead of saying kubectl create secret. So they work with a different object, and then there's a controller underneath the hood that will automatically encrypt and decrypt and create secrets for you. That way your application doesn't know the difference, and that allows you to store an encrypted value in your YAML file if you're using Argo CD. So you can be fully fledged GitOps. This doesn't always tick all the boxes for many security people or companies that are very concerned about security. They may still not use this mechanism, and they prefer something like a key vault where secrets are kept totally outside of Kubernetes. For this, there are external what's called storage drivers and secret drivers that Kubernetes allows you to install, and cloud providers generally seamlessly integrate with their vaults. For example, if you're deploying AKS to Azure Kubernetes Service, you can integrate with Azure Key Vault. If you're going on AWS, you can integrate with their secret manager and their secret solutions. You can also integrate with something like HashiCorp Vault as well. Kubernetes gives you that flexibility to either use the built-in secret store or use something completely external to Kubernetes. It's also important to notice that secrets in Kubernetes can be protected by RBAC. So you can design your cluster in such a way where teams can say kubectl apply or create secret, but then protect the secret object itself so nobody can say kubectl get secret and retrieve them. So you can make it so that secrets can go in but cannot come out. You can limit and restrict secret access to certain individuals as well. So in Kubernetes, there are role-based access controls called RBAC, where you can secure secrets. So it's just important to understand all of these different components, because depending on the company you work for, they might have different policies around secret management. But Kubernetes should provide you with the basics of having good hygiene around secret management. So hopefully this video was informative if you're new to Kubernetes and new to secrets. If you liked the video, be sure to like, subscribe, and hit the bell, and check out the link down below to the DevOps course to follow the progress on the Ultimate DevOps course development. At the time of this video, we're busy working on chapter 3. And if you want to support the channel even further, be sure to hit the join button down below and become a YouTube member. And as always, thanks for watching, and until next time, peace.